Okay, so here's a challenge question on using the normal approximation to the binomial distribution. So let's have a read through this. So in a large school, 20% of students own a touchscreen laptop. A random sample of n students is chosen, and then we're asked to use a normal approximation. So the question is telling us to do this. Using that, the probability that more than 55 of these n students own a touchscreen laptop is 0.0401. So they're telling us a probability. It's going to be an inverse normal when we get to this in a minute. And they're asking us to find the value of n. You can see it's a past exam question and it's worth 8 marks. But this is all the question is, it's worth 8 marks. It's definitely going to be a multi-step question where we've got to think through the steps ourselves. Okay, so let's have a look. Well, first of all, x, my random variable, is going to be the number of students who own a touchscreen laptop. So I'm defining my variable to begin with. And this is definitely discrete because it's a number of students. There's only 5 students or 6 students or 20 students. Okay, so x, now it's binomial. N, we don't know. The number of students involved, the number of trials, we don't know. So n is just n, variable. And the probability of success is this, it's 0.2. So the probability of actually having a touchscreen laptop is 0.2. So there's my binomial setup. Okay, we're told to use a normal approximation, so let's have a look at doing that. So the mean mu, using my formula, is np, so in this case it's 0.2n, and my variance, my standard deviation squared, np, brackets 1 minus p, so that's going to be 0.2n times 0.8, so 0.16n. Okay, so my normal approximation is going to be new variable y, which is normal and is continuous now, normally distributed, 0.2n for mu and 0.16n for sigma squared. And again, let's not forget this is sigma squared, so that's going to mean that sigma, my standard deviation, is the square root of all of that, and I might as well simplify that down, 0.4 root n. So that's my standard deviation that I'm going to need to use a little bit later on. And what are we told in the question? We're told that the probability that x is greater than 55, that more than 55 students own a touchscreen laptop, we're told that probability is 0.0401. Okay, so let's have a think about converting this then to the normal. So first of all, we're going to have to think about our continuity correction. Okay, so let's just think about a number line. So let's go 53, 54, 55, etc. We want greater than 55. So this is the part that I want. So using a continuity correction, if it was just binomial, that's fine. We do 1 minus less than or equal to 55, but because they want us to do a normal approximation, I've got to make this a normal continuous variable. So this is going to be equivalent to greater than or equal to 55.5 there. And we know that that probability is equal to 0.0401. Okay. In here then, we still haven't got n involved, we still haven't got a variable involved. And what we're going to do, and we've seen this before when we've looked at questions where we're asked to find mu and sigma, what we're going to do, we're going to use the standardised normal distribution, because that will then get the mu and the sigma involved. So it'll get n involved in our equations here. So let's do that. So what we're going to do, to find n, we're going to use the standardised normal. Sorry, my writing's gone a bit dodgy there. And if you remember, to standardise the normal, you take mu off your variable and you divide by sigma. And z is our standard normal distribution with mean 0 and standard deviation 1. I'm just going to get onto a new piece of paper. So let's convert our question, which is y is greater than or equal to 55.5. Let's standardise that. So that's going to give me, if I standardise that to z, whatever my normal variable is, I take the mean off, which in this case is 0.2n. I divide by the standard deviation, which in this case is 0.4 root n, and that probability, we're told, is 0.0401. Okay, quick sketch. So the probability of being greater than whatever this z value is 0.041, so 4%, so that's up here somewhere. Okay, and so what we're going to do now, we're going to use our inverse normal function to give us this value of z here. So what's that value of z? We're going to use our inverse normal to do that. So I'm just going to write that down. So now use the inverse normal function, and that's going to give us a value of z. Okay, so let's have a look at that. Don't forget then, on your inverse normal function, it does the area up to this, so we're going to have to make sure we take this off 1 to get this bit of the area here. Okay, so let's just do that. Make it a less than or equal to rather than a greater than. And don't forget, because it's continuous, whether I do less than there or less than or equal to makes absolutely no difference. So that's going to be 1 minus this, which is 0.9599. Let's then do our inverse normal function on our calculator, a reminder of where that is.